Hello friends, this is Prasant Raj Soha. Today brought up with a new topic, stability of slope. Now let us talk what is the stability of slope. So the slopes can be of many types. So let us see, it can be natural, it can be man-made, and also it can be classified according to the extent. So natural slopes, those existing in the nature formed by the natural causes, and the man-made slopes are those the cuts, embankments, or the dams, etc. Now slopes are classified according to their extent as infinite slope, finite slope. In infinite slope, the constant slope of infinite extent, that is mountains. Finite slopes, the slopes of limited extent. For example, cuts, embankments, etc. The result of failure of a natural or man-made slope can be catastrophic, very dangerous. Hence, study of slope stability is very important. Now let's look towards the stability analysis of infinite slopes. Consider an infinite slope AB inclined at an angle I to the horizontal. So this is the slope AB at an angle of I to the horizontal. Failure of slope involves a sliding soil mass along plane parallel to surface at some depth. Let CD is such a failure plane at depth Z. So this is the failure plane at the depth of Z. Consider a portion of soil mass PQRS of width B along inclined surface. So let us consider this is the portion of earth or the soil mass with the width B. So the width of this slope is B. Weight of this portion is W, which is given by gamma ZB cos I. Vertical stress on CD is sigma Z is equals to W by B. So components of vertical stress parallel to CD and perpendicular to CD are sigma equals to sigma Z cos I equals to gamma Z cos square I, and tau is equals to sigma Z sin I. Tau represents the tangential component. You can even say it as a T. A tangential component T parallel to the failure surface CD is the shear stress causing failure. The shear stress is resisted by the shear strength Tf of the soil. Hence, the factor of safety against sliding is F is equals to Tf by T. The shear strength includes cohesion and internal friction. Tf is equals to C plus sigma tan phi. Two cases are considered here, cohesionless soil and cohesive soil. So the case 1, let us see cohesionless soil. Let OA is Coulomb's failure envelope for cohesionless soil defined by the equation Tf is equals to sigma tan phi. Failure condition for an infinite slope of cohesionless soil. If I is greater than phi, the line OF representing stress on the failure plane meets the failure envelope at F. At F, shear stress is equal to shear strength, that is, failure happens at F, and F2 represents shear stress at some depth Z. C1, C2 represents shear stress at some depth less than Z. At this depth, shear strength is CC2. Hence, for any depth less than Z, shear stress is less than shear strength and the slope is stable. Example C1. Failure condition for an infinite slope of cohesive soil. Hence, if I is greater than phi, slope is stable only for depths less than Z, known as critical depth HC. Factor of safety for any depth Z less than HC can be given as F is equals to Tf by T. equals to C plus sigma tan phi by T, where we have the relation sigma is equals to sigma z cos I, T is equals to sigma z sin I. So from there we can conclude this equation of factor of safety. At the critical depth at C, tau is equals to Tf, that is F is equals to 1. So from there we can calculate the critical depth. As we can see, at the critical depth factor of safety is equals to 1. So when we equate it with 1, we can get the critical depth. Thus, for given values of I and phi at C, that is critical depth is proportional to cohesion C. So C by gamma at C equals to tan I minus tan phi into cos square I, that is Sn, which means stability number, and it is a dimensionless quantity. Now, causes of failure of slope. First and foremost is the gravitational force. Due to the gravitational force, the soil debris can fall. Force due to seepage water. When the water gets percolated inside the soil, it may fall down, or it may cause landslides. Surface erosion due to flowing water. Flowing water always carries the surface layer of the soil, so it can erode the surface. Sudden lowering of water adjacent to the soil. When the water falls directly to the ground, it may also cause failure of the slope. And the earthquake. Earthquake causes a drastic change in the structure of the soil, which causes failure of slope. Thank you.